Welcome to Summarize Science, where we break down complex research into simple terms. Today, we're looking at a fascinating question. Can an AI learn to predict numbers that are supposed to be unpredictable? This paper studies if transformer models can crack sequences from permuted congruential generators, or PRNGs, which are a widely used type of pseudo-random number generator. PRNGs are designed to be tough to crack because they take a simple mathematical sequence and then scramble the output using bitwise shifts and rotations. This makes their patterns much harder to spot than simpler generators. The challenge for the AI is to essentially reverse engineer this hidden process just by looking at the final numbers. And as you can see from these graphs, the AI was remarkably successful. After being trained on numerous example sequences, the transformer model learned to predict the next number with over 90% accuracy. It even managed to learn the patterns of several different generator types all at once, a task that would be incredibly difficult for classical analysis methods. This shows that transformers are capable of uncovering very deep and obscure mathematical patterns in data. However, the task wasn't always easy. As the generators became more complex, the model needed to see more numbers in a sequence before it could make an accurate prediction. The researchers discovered a scaling law, shown here, which means the difficulty of the problem grows in a very predictable way. For the most complex generators, the researchers found that the AI couldn't learn effectively if it was only trained on the hard problems from the start. They needed to use a technique called curriculum learning. This is just like how humans learn in school. You start with easier material and gradually build up to more difficult concepts. This chart clearly shows the benefit. The green line represents the model trained with a curriculum, and it learns far more effectively than the model represented by the blue line. This suggests that for some advanced tasks, a step-by-step teaching approach is critical for AI. Perhaps the most incredible finding was what the researchers discovered when they looked inside the AI's brain. This chart visualizes how the AI organized the numbers it was learning. It wasn't just memorizing, it was spontaneously grouping numbers based on their underlying structure, like the arrangement of zeros and ones in their binary form. This internal organization is what allowed the AI to transfer its knowledge from easier problems to harder ones so effectively. It was building a fundamental, general understanding of the numbers. So, let's recap the important points and what they mean. First, transformers can learn hidden mathematical patterns that are far more complex than previously demonstrated, even outperforming some targeted classical attacks. Second, for truly hard problems, curriculum learning is a critical strategy to guide the AI to a solution. Finally, by studying the model's internal representations, we can see that it builds logical structures to understand the world, which is a huge step forward for AI interpretability. This research provides a powerful new benchmark to test the limits of AI reasoning. It also opens up new possibilities for using AI in fields like cryptography and theoretical science to discover patterns that humans can't see.